Okay, in this video we are going to talk about a couple of different things, one being product to sum formulas and the other sum to product. So essentially what we're looking at here is if we start with a sum or a product of trig functions, we can use a formula to rewrite it as the opposite. So in this first example we have sine of 3x times sine of 5x. We want to rewrite this as a sum. So I'm going to find my pattern here. We're going from a product to a sum, and I have sine times sine. So it's going to be this last one. And it says that we're going to do 1/2 of cosine of a minus b minus cosine of a plus b. So our a is 3x, our b is 5x. That's what it's in place of a and b here. We're going to do a minus b and then a plus b. Okay, so we're going to do 1/2. And then we're going to do the cosine of a minus b, and then minus the cosine of a plus b. So 3x minus 5x, and then minus the cosine of 3x plus 5x. Okay, so that's going to be 1/2 the cosine of negative 2x minus the cosine of 8x. If you look on your cheat sheet at the even-odd identities, cosine of a negative angle is the same as the cosine of that positive angle. So I'm going to switch out negative 2x for just 2x. So I have 1/2 times the cosine of 2x minus the cosine of 8x. And then I'm going to distribute that 1/2 so that we have it as a sum here, which is actually a difference, but it's the same idea. So 1/2 cosine of 2x minus 1/2 cosine of 8x. Alright, next example we're going to do the opposite. So we're going to go from a sum to a product. So here we have sine of 7x plus the sine of 3x. So if I go from a sum to a product, we're going to use this formula. So we're going to do 2 times the sine of a plus b over 2 times the cosine of a minus b over 2. So here a is 7x and b is 3x. So we've got 2 times the sine of 7x plus 3x over 2 times the cosine of 7x minus 3x over 2. I just want to make sure I did that right. So it's a plus b, sine of a plus b over 2, and cosine of a minus b over 2. Okay, so then we can simplify this down a little bit. So this is going to be the sine of, well, we'd have 10x over 2, so that's going to be 5x. And then the cosine of, that would be 4x over 2, which would be 2x. And we will just leave it like that. Okay, so we've taken our sum and rewritten it as a product. Okay, in this last example, we're going to prove this identity. So we're going to use these ideas of going from a sum to product. I'm going to start with the left side, and notice I have sine minus sine. So that is going to be the second line of this, where I'm going to go from a sum to a product. So cosine a plus b times sine a minus b. Okay, that's what I'm going to do on top. So I'm going to say left-hand side equals, and again we're using this sine minus sine. So 2 cosine, so 2 cosine of a plus b, so 3x plus x over 2. And then it's times the sine of a minus b over 2. So the sine of 3x minus x over 2. That's just the top. The bottom we have cosine plus cosine. So cosine plus cosine, that's this bottom. 2 cosine a plus b over 2. Cosine a minus b over 2. So 2 cosine of 3x plus x over 2, cosine of 3x minus x over 2. Now before I start simplifying a ton here, what I'm noticing is that these two things are exactly the same. My 2's will cancel, and I have cosine of 3x plus x over 2. That's going to cancel with cosine of 3x plus x over 2. So we're essentially just going to be left with sine of 2x over 2. Right? So 3x minus x is going to be 2x over 2. That's just going to be sine x over cosine x, which is equal to the tangent of x, which is our right-hand side. So there's just proving an identity using a sum to product formula. Sum to product, product to sum can be useful to help you evaluate certain angles, but all you're doing here is finding the pattern, or finding the setup that you want, and then following the pattern and evaluating.